Problem 7.12. This is a very interesting problem. It has two parts, A and B. So the first part asks find any time between 1 p.m. and 2 p.m. such that the hour and minute hands of a clock form an obtuse angle, and give your answers in hour and minute form. So it has asked that if you have a 12 divisions of a clock and the hour hand is somewhere between 1 and 2, where would the minute hand be such that you have an obtuse angle between the two hands, the hour hand and the minute hand? So this is a fairly easy problem because we know that between the hour 1 p.m. and 2 p.m. the hour hand has to be somewhere between 1 and 2. These markings 1 and 2 of the clock. That means that it cannot be past 2. It cannot be past this 2 marking because it's between 1 and 2 p.m. So select any marking and put an hour hand there. Let's call this the hour hand, the shorter hand. And the minute hand will have to be at least 90 degree more. Our angle is 90 degree with this hour hand. So for example, if it is 1:30, I can have the minute hand pointing directly to this marking 6, and it will have to be more than 90 degree. It will be more than 90 degree. The first part of the problem is asking for any time, so that doesn't restrict us to a particular time period. It can be any time. So let's draw this. So this is your hour hand. And we can see that this is more than 90 degrees, so that is an obtuse angle. Why can we see that? Because by mathematics also we can explain that. How many divisions are there in this total 360 degree of the dial? The division made by 1 hour to the next hour marking is 30 degrees. Why? Let's say the division made is, let's call it n degrees. And how many such division is there? N degrees is between 1 and 12, same as between 1 and 2, 2 and 3. So how many such divisions are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 divisions, each having n degrees. So that means 12 times n degree is equal to 360 degrees, or n degree equals 360 divided by 12, and then you can cancel the factor 12. You get 30 degrees. So the spacing between 1 hour mark and the next hour mark is 30 degrees. We know that the hour hand will not cross 2. So counting starting from 2, this is a 30 degree, a 60 degree, a 90 degree, and a 120 degree. So the angle, whatever that angle is greater than 120 degree. Therefore it must be an obtuse angle. That's what they're asking for. Any time which is having an more than 90 degree between the two hour hands. We chose the that mid-hour mark so that it's easy to calculate for us. But you can choose anything. You can choose 135 or even 140 and so forth. So that angle will still be more than that. So this is your first problem, the angle, the time. (1:30 p.m.) has hour hand to minute hand angle more than 90 degrees or obtuse. Okay, so that is your first part. I should call it part A. So I'm calling this part A. Now let's do the second part. Let me adjust the camera. Okay, let's do the second part. Problem 7.12b. I drew again the clock, and we will start the we'll start placing the hour and minute hands. Now the second problem is actually more complicated. In fact, that will require if you are not very sure yet about forming equation or solving equations, I would request you to go check the previous videos in this topic 7 before you come here. So definitely this may be a little bit more challenging to understand for the beginners. The question is asking, what is the earliest time when the angle between the hour hand and the minute hand becomes obtuse? So of course the hour hand has to be between 1 and 2, and the minute hand at the start of the hour is at 12, and that minute hand is moving faster than the hour hand, of course, and at some point the minute hand and the hour hand angle is 90 degrees. Just the minute after that, the angle becomes an obtuse angle. So they want us to find at what angle or what time does this change from a 90 degree angle to an angle greater than 90 degree or an obtuse. That what is the earliest such time? Because any such time which we have done in problem A or part A of this problem, we already found that it's 1:30 or 1:35 even. But they want to find the earliest such time during that 1 o'clock hour that this is happening. In order to do that, let's start from 1 o'clock. So at 1 o'clock, the hour and the minute hands are located just like this. The hour hand is pointing to the 1 hour mark, and the minute hand is pointing to the 12-hour mark. As the time proceeds, the hour hand is moving to the right, but at a slower pace than the minute hand. So let's compare the speeds. So let's compare hour hand HH, we call it HH in short, moves 30 degrees in 1 hour or 60 minutes. Or 30 divided by 60 is half a degree, or half a degree in 1 minute. So that's the speed of the hour hand. Let's put a bullet. As for the minute hand, moves. Now it moves 360 degrees in 60 minutes. Or 360 divided by 60 is 6 degrees. So 6 degrees in 1 minute. Now, let's say the earliest time is 1 hour, or 1 and x minutes. 1 hour, or x minutes past 1 hour. That's the best way to say it. X minutes past 1 hour. So let's make a statement here. Let the time required be x minutes per hour, or x minutes after 1 o'clock. So this statement means basically that at x minutes past 1, you have a 90-degree angle between the hour hand and the minute hand, and right after that you start having an obtuse angle. So how much movement has happened? Let's put some dotted lines for that. Let's say the hour hand has moved to this position. And the minute hand has moved to some position which is 90 degree of that at least. This should be a dotted line. Okay, and this is a 90 degree. So how much has the hour hand moved? The hour hand, if I draw faint lines to represent the angle, let me draw that. I hope you can see it. So the hour hand has moved in x minutes. The hour hand will move x times the speed, which is half a degree per minute. So it must be half times x, or x by 2 degrees. And the minute hand has moved this whole angle going from here up to here, this whole angle, is x times its speed, which is 6 degrees per minute, or 6x. So let's just write it down. In x minutes, HH moved half times x degrees. In the same x minutes, MH moved 6x degrees. So let's look at again. Let's form the equation. Here is the situation where we can form the equation. This 6x, this whole 6x is built by this angle, which you know that it's one spacing between one marking and the next hour marking. We know that this is 30 degrees. Then this angle, this tiny angle, which we know that it's x by 2 degrees, and then the 90-degree angle. Okay, so let's write (30 degrees) plus x by 2 degrees plus 90 degree equals 6x. Now we can remove this degree designation, just use the numbers, and in this step we can also put the known numbers together. X by 2 plus 120 equals 6x. We flip the equation. 6x equals x by 2 plus 120. Why did we flip it? Because as a convention we have the variables on the left side, so that's why I flipped it. You can take this on this side of the equation, or 6x minus x by 2 equals 120 degrees. Or you can take 2 common. Remember, 6x is actually 6x over 1. So you can take 2 common. This becomes 12x minus x equals 120 degrees. Or 11 by 2 x equals 120, or x is 2/11 of 120. Which is 240 divided by 11. So this would be try to do a quick division here. So the answer is 21 9/11. So at 21 and 9/11 minute, the hour hand is at 90-degree angle with the minute hand. At the very next minute, which is when, let's say, 22 minutes past 1, at that moment, it is already obtuse. So because we have been asked to provide the answer in hours and minutes, you can say at 1:22 p.m. the HH and MH are first at an obtuse angle. And this is your answer, 1:22 p.m. So let's go over this problem one more time, at least the second part of the problem. We start at 1 o'clock. The hour hand is at 1 and the minute hand is at 12. As we move past 1 p.m., the hour hand moves at half a degree per minute, and in x minutes it goes x by 2 degrees. The minute hand goes at 6 degrees per minute, and so in x minutes it has traveled 6x degrees. Now at this point, x minutes past 1, these two hands are at 90-degree angle. So if I have to reconstruct 6x degrees, which is this entire angle, that means that the first 30 degrees it has to cover, then the movement covered by the hour hand, which is x by 2 degrees, it has to cover, and then it has to cover another 90 degrees. And that is how we wrote this equation. 30 degrees plus x by 2 degrees plus 90 degrees equals 6x degrees. And then we solved for x. We found x to be 240 divided by 11, and that is 21 9/11. And at 1:22 p.m., which is the full whole minute, which is the 22nd minute, the hour hand and the minute hand are first at an obtuse angle. So this is the earliest time in that hour 1 p.m. to 2 p.m. that these two hands are becoming obtuse angle. Because the minute hand is a faster rotating hand, the angle keeps on increasing as you go further at 1:23 p.m., 1:24 p.m. and so forth. But the earliest time that they are at an obtuse angle is at 1:22 p.m. Hope you enjoyed this problem. This is a little bit complicated, as I said, maybe a little bit for the advanced students for pre-algebra. So if you are confused, I would say that stick to 7.12a. That's a simpler problem, and once you have mastered the idea or the art of forming equations and following complex logic, then maybe you can come to this and do this problem successfully. Thanks.